factoring trinomials. So where before, as we did before, we were multiplying binomials, and when you multiply binomials together, which you just did on that worksheet that I just went over, you end up with a trinomial. Okay. So what factoring Tony, what factoring a trinomial means is you're breaking this trinomial, this three-term expression, into two binomial factors. For example, say I have x squared, and I have x squared plus 7x plus 12. And what they say is factor this. Okay? So you could use the box method for this. I'll show you a couple different ways to do it. Okay? One way is to draw a box. So I'm going to try to draw a box. This is how I draw a box. That's how I draw a box. But now you're going backwards. Okay? And so here's a box. And what goes in this part of the box is the x squared. And what goes in this part of the box is the 12. Okay? So in the box you put this and this. And then what has to go here and here to make an x squared? An x here and an x here. Because those are the only things that are going to multiply to x squared. Now here's the trick. Okay? You got to figure out two numbers that multiply to 12, right? Because that's what's going to go here and here. And they have to, when I multiply those two numbers together, these are going to be my like terms. So they need to add to this. So this is like the product over here. Product. And this is like the sum over here. All right?
Did you ever use the cross, or are you going to do that next?
I'm going to use the cross, yeah. So think about it. What two numbers multiply to 12 and add to 7? Go ahead, Cole. Perfect, okay? So you put, and it doesn't matter which one you put where, okay? So put a 3 here and a 4 here, and then you're done, okay? Except not quite, because this is actually, that's not where they should go. Sorry. They should go 3 here and a 4 here. And then over here, I have my 3 times x, which is 3x, and my 4 times x, which is 4x. And these two add to 7x, and these add to 12. So when I rewrite this thing, I know that x squared plus 7x plus 12 breaks apart into x plus 3 times x plus 4. Okay? And that's called factoring a trinomial. And you might say, why would I ever want to do that? And I will tell you, because there's lots of quadratic equations, like things that have x squares, that come up in real life. Like when you're talking about throwing an object in the air, or launching a rocket ship, or all kinds of business applications. And a lot of times you want to see how to solve that quadratic equation. And to solve that quadratic equation, you need to first factor. Okay? So let's try another one. There's lots of them. G squared plus 7g plus 10. Okay? G, and they like to use different letters because they like to confuse you. G squared plus 7g plus 10. Now you could use the rectangle method. Now what Miss Lindgren, years ago when I used to teach in California, there was this method they called the cross method. Okay? And up here they call this the product. Product means multiply. Okay? And so you put this in the product area, and you put this in the sum area. Okay, so this is the sum. So think about, and sometimes it's just simpler for people to think about it. like this. What two numbers multiply to 10 and add to 7? Who's got it? Raise your hand.
2 and 5.
2 and 5. Very good. And that's up. Like you could have said, so what I usually do if I can't think about it, I say, okay, let me see. There's factors of this. 2 times 5 will give me 10. 10 times 1 will give me 10. That's it. It's either got to be 2 times 5, right? Or 1 times 10. And 1 times 10 doesn't add to 7, right? So you put a 2 on one side of the cross and a 5 on the other side, okay? And then that means that this factors to g plus 2 times g plus 5. And that's all there is to it, okay? Unfortunately, it gets harder. Why? Because that's the way math is, okay? I thought like I got through calculus and I said, oh, I'm done now. They say, no, you got to take calculus 2. No, you got to take, oh, I'm done with calculus 2. That was fair. Okay, now you can take calculus 3. You have to run with that. Oh, now you can take differential equations. I can't even think of the math that they do in like grad school. Like my friend, he just got his PhD. Oh, I should stop. I'm going to throw in some negative signs. D squared minus 17d minus 17d plus 42. And this is where it could get a little bit trickier. Should we use the box method or the cross method? The box? You like the box better? Okay, we'll do the box this time, then next time we'll do the cross method. Okay, so where's my boxes? These are my boxes. Let's make a box. Okay, so make this box. Where's my lines? So something has to go in here. What goes in here? What has to go here?
D squared.
D squared. What has to go here?
42.
42. So now what I have to do is figure out two numbers that multiply to 42 and add to negative 17. So that's a little bit tricky, okay? Because you have to kind of be able to do some math in your head.
Well, they both have to be negative.
They both, very good. So what Fred said is they both have to be negative. Because only way, so we'll worry about the sign later, right? So if this is positive and this is negative, a negative times a negative gives you a positive, and a negative plus a negative gives you a negative over here. See? So what are some factors of 42?
7.
So there's 6 and 7, but there's no way to put 6 and 7 together to make 17, right? What else are some numbers?
5 and 8.
5 and 8? Not 5 and 8? This is kind of a weird 6. 6?
You already have
No.
6.
I just
How about 21 and 2? That works, right? But that doesn't add to negative 17. Can anyone think of another one that's not like one of the most obvious factors?
Well, 42 and 1, but that still does not work.
Do you guys know how to tell if something's divisible by 3?
13.
Do you guys know how to tell if a number is divisible by 3?
No.
If you add up the digits?
14.
Wait,
What? Oh, yeah, if you add them up.
if you add up the digits, and if that number is divisible by 3, then the number is
14,
divisible by 3.
28, 42.
14 and what?
Times 3.
4, very good. 14 times 3.
Amen.
Okay? So that's actually what goes here. 14 and 3. So that one's not completely
Good job.
obvious, right? Very good.
Did you negatives on them?
Okay? Yes. And then, because this is negative, both of them have to be negative, right? Because I want them to add to negative 17, not positive 17. So over here you have your minus 3d, because that's that times that. And over here I have my, oops, that should be a d there as well, minus 14d. Okay? So this thing, if I want to factor it, okay, factors to d minus 14 times d plus 14. minus 14, d minus 3. D minus 3. So that's how that factors. Should we do 7 more?
No.
Sure,
Yeah.
why not?
Okay. Let's, maybe you guys could try. Okay. We're going to try, you try.
Wait, do one with the cross before we do it.
Okay. Okay. Before we do you try, we'll try one with the cross. Okay. X squared minus 10x plus 25. So here's how we do it with the cross method. Factor. All right. Factor. If you do it wrong, you know what that's called?
What?
Failure.
And you see that that's the right answer? If you say if it's wrong and you say that it's the right answer,
What's it?
no, that's called factor fiction.
Yeah.
That's a good one.
Factor fiction. See? Because you made it up, you know, and it's a factory. All right, so you get that?
Is this a you try?
No, we're just going to do it. Okay. So here goes the product. The product goes up here. This is the product. And this is the sum is negative 10. So what you're looking for is two numbers that multiply to negative 10. Excuse me, that add to negative 10 and multiply to 25. 5 and what?
5.
Positive or negative?
Negative.
Negative 5, negative 5. Perfect. Okay? Those multiply to positive 25 and add to negative 10. So this factors to x minus 5 times x minus 5. Okay? Or just x minus 5 squared. Just so you okay, now we'll try you try.
Yay.
You ready for you try?
Why not?
You try.
You say so.
You try.
Wait,
That's
One
not
Direction
wrong.
concert.
What?
2013.
Oh, here I see two.
I'm having trouble here.
Oh, okay, I get that.
July 24th.
Oh, that's not how you spell you.
No, it's Y-O-U.
How about try? Is that what you do? X squared
That was a good a name of
minus 11x
That's good.
plus 18. So, the answer to that was this. Yeah, we're going to do another one with some subtracting in there. Okay? So, say we have one that looks like this. P squared minus 3p minus 18. So in this case, I have to think of two numbers that multiply to negative 18 and add to negative 3. So the easiest way to do it is think about all the factors of 18, right? And then see what combinations of those factors add up to negative 3. Now here's a hint, okay? If these things are both negative, right? One has to be positive and one has to be negative, right? Because a positive times a negative will give you, that's only a combination that will give you a negative when I multiply them. And if one is positive and one is negative, then this could come out to be a negative, okay? So let's see who could figure this one out. Where's the smart kid?
What are you talking about? They're all smart.
Oh, they're all smart, sorry. Who's got it? Go, 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 go. Come on. Someone other than Fast Freddy. You have it? Emma? Is it?
What about Reed?
Yes?
It's really fun.
Is that what you got, Cole? Negative 6 and
Huh?
positive 3. Very good. Okay?
You're into that.
Negative 6 and positive 3, right? Because negative 6
Well,
times 3 gives
I
you
think it's
negative
bad,
18.
but I still without
And
that.
negative 6 plus 3
Logo.
gives you negative 3. So this factors to p minus 6 times p plus 3.
Do you always put the larger number in front?
Doesn't matter. It doesn't matter if I put p plus 3 in. Doesn't matter which one. Okay. Here's a tricky one. Here's another you try. I'm doing lots of them because I think this is something that you need lots of practice. Okay? Y squared minus y minus 56. Well, who thinks they got that one? These numbers need to multiply to negative 56. Now you got to know your times tables a little bit. And add to negative 1. Who's got that one?
It's -8 and 7.
Negative 8 and positive 7?
Yeah.
That's it. Nice job, Maddie. So that's y minus 8, y plus 7. There you go. All right. And then they're going to give you something that looks ugly like this. Last one, I promise. Okay? I promise. Last one. All right. So, u squared minus what? U squared. I'm trying to do squared. I think that's an H. I can't read my own writing.
Oh, well,
That's
whatever.
H.
Just
H squared minus 4hk minus 77k squared. K squared. So this looks really confusing, but don't be confused. All you're really doing is these two numbers still need to multiply to negative 77, and they need to add to negative 4. Okay? So what multiplies to negative 77 and adds to negative 4? There's only so many things I can.
11 and 7.
Very good. So which one's positive and which one's negative?
-11.
That's negative, and that, whoops.
Oopsies.
That one's, this is negative, and this one is positive. Now, why is HK here? Because, let me just show you, okay? Because if I'm doing the box, this is kind of where you have to look at the box as well. Where's the box? Here's the box. If I'm looking at the box, okay? And I put the h squared in here, and the minus 77k squared here. What has to go here and here?
Put it over H and then
H and H. And here's your minus 11, what? K, right? Because, and here's 7k. Because this times this is going to give you 7hk. And this times this gives you negative 11hk. And if I add these two together, I do get negative 4hk. And this times this does give you negative 77k squared. So there's a few in this and where you have variables here and variables here. Okay? And just don't freak out. You're doing the same process, but you have to put some extra letters in. Okay? The answer to this would be that's equal to h minus 11k times h plus 7k. Just like that. So your homework is,
no more.
okay, read it and weed. Some of these are shorter than others. Okay? Page 438. 483, isn't it? 483. Isn't it 483?
I don't know.
I have 483.
483.
1 through 38, and then 43 through 55, and it's every third. Every
All of them?
third. No, so that means you do 1, then you do 4, then you do 7, then you do 10, until you get to 38, okay? And then you start with 43, and then you 45, 46, would that be 47? 44, 45, 46, 49, right? Etc. So, see how many of those you can do. Yes, Izzy? Nothing. this back?
No.
Yeah,
Yay!
as soon as this stops. It's supposed to stop now. Oh, have I been paused that whole time?
No.
No, you were recording the whole time.
You're still recording.